Hey everyone, good morning and good evening. Hopefully, everyone has utilized the extra time given and you guys have practiced. So, this is how I do it, guys. This is how I give you guys extra time every time so that you guys can go back, practice whatever is left. Because I know this is a lot of tool what we are learning, and if I don't give you extra time, there is a great chance that everything will get overlapped. Make sure to utilize this time because we are spending extra days over here to utilize your time practicing whatever we have done. Okay, again today I'll be introducing you to a new tool. So once this tool is done, again I'll try to give you some extra day so that you guys can go and practice. Okay, I know everyone is a working professional over here. Removing time from the day-to-day activity is very difficult, but we don't have any options, we have to do it. Okay, so let's start with and let's see what exactly we are doing today. And before that, anyone, any questions, any doubt, any query, anything? Anyone has anything to talk about? Not just query, anything, guys. Feel free. If you have anything, please do let me know. No queries? No problem. Okay, because I get lots of query directly to me. So if you have any queries, put it in the group or ask it in the group so that, because there are similar queries which you guys are asking again and again. So it's all the group will get benefited out of it. Okay, so today very important topic in DevOps. We'll start with DevOps, guys. So we'll understand what is DevOps and all later. So I'm just trying to do a change over here. The theory part I'll do it later. We'll start with the practical and the tool part itself first. The first tool which I am starting with is Git version control. Anyone has any idea what exactly Git is? Anyone wants to say in one line what exactly is Git? If I ask you, what do you
Yeah,
say? Yeah.
Git. Basically, let me use a very basic description.
Mm-hmm.
It is a version control, basically like a repository where you put all the codes you're using to
Mm-hmm.
build your applications.
Perfect. Perfect. Anyone else wants to add something? No one? Okay. Other question. What is the difference between Git and GitHub or GitLab or Bitbucket?
So,
Yeah.
Git, the GitHub, I would say, is more kind of like the storage,
Mm-hmm.
while the Git itself is like a tool to operate the code and the storage, the GitHub.
Perfect. Very good. So yeah, as rightly said, Git is a tool wherein GitHub is a storage, a cloud provider wherein basically you can store your code. And nowadays they have more features. You can distribute, you can version, and nowadays they even have pipeline option through which you can start building your packages and things like that. So there are many things they are doing, but what's the core responsibility? It's to store codes. That is what GitHub and GitLab, Bitbucket, Azure Repo, they are all about. Okay, wherein on the other hand, Git is nothing but it's a version control tool. Rightly said. Very good. Okay, let's start. The first thing, we have a prerequisite. I believe everyone has installed Git. If not, please go on Git for Windows. And if you are using Mac, then there is Git for Mac also, guys. Just go and download Git. Okay, so this is the second link. Go into the second link. Download this 64-bit Windows installer setup. This is a exe file, guys. So once you download, just you have to do next, 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 and Git will get auto install. 64, I believe everyone is using 64 nowadays because there is no 32. 32 was during the era of Windows 7 and XP. So I believe everyone is Windows 10 and above. And Mac. So guys, if you go back and if you want to look for Mac, if anyone is using Mac, just put Mac over here. You'll have download. How do we download for Mac? See, brew install git, and on Mac it will get installed. If anyone is using Linux, so by default Linux has git if you're using Ubuntu. If not, if you're using RHEL or something, so yum install git will get installed. That easy it is. Okay, once the git is installed on Windows, you'll find something like git bash, git GUI, git cmd. Bash you have seen me using multiple times because I was connecting to the VMs using git bash. We all know what exactly is bash now. Bash is a shell, a Unix shell which has multiple additional features of auto completion, history, and things like that. Git GUI is a command line, it's a graphical user interface. So this is not that user friendly, guys, so I'll not recommend people using this GUI. Okay, I'll show you which GUI you can use it for, make your life easy. This GUI has very limited feature of creating repository, cloning repository, opening existing repository. That's it, nothing it has more. Okay, that is the reason I don't recommend this. The third and the last is git cmd. This is if you guys are familiar with DOS, MS-DOS. Okay, so this will make more sense to you. All your DOS command will work. All your DOS command, all commands will work. If you are familiar with DOS, then you can make use of it. Okay, see, these are the DOS commands. If you want to list, dir is the list, cls is to clear the screen. These are all MS-DOS command. So if you're familiar with this, you can please use it. Git command will not change much. Whatever command I'll be running in bash, 90% of time the same command you'll run it on DOS also. Okay, what we will be using for git, as I said earlier, we'll stick with bash. We are all familiar with Linux basics commands now. So can we go and run all the basic command? Using the basic command, can we work with git? Yes, definitely we should work with git using bash shell. Okay, so we'll go with very scratch, guys. We'll start with very basic git commands. Now when I take interview, people tend to say, why do we need git? When I start asking git questions, then I get back questions, then why do we need git as a DevOps engineer? Not just a DevOps engineer, I might have said this earlier during my demo also. Git is a very important tool if you want to be in IT world right now. Even though if you are in L1, L2 support, at the minimalistic support role you're doing, you should know what is Git. Because when the developer or when the other team will ask you to run some sort of script on some sort of server, they will not attach that script in an email and send it to you. They will send a Git link, ask you go and clone it and run it on the server. And if you don't know the basic cloning, so just imagine the state you are in right now. So over there also you'll require Git. Being a DevOps engineer, there are n number of times you'll be using Git. Git is the backbone wherein you will be setting up your branching and merging strategy, wherein you'll be putting all the source code. You'll be defining which branch will play what role, how your pipelines will be built, how your release pipeline will be there. All these will be defined on top of your branching and merging strategy, and that branching and merging strategy will be placed out of Git. So imagine the amount of Git you will be using yourself. You will have to set up all the policies, you will have to create the branches, and the scripts which you will create, your build pipeline, your release pipeline, where you will put it, you'll have to put it in the Git itself. Correct? Nowadays we are in the world of infra as a code, pipeline as a code. All this, where exactly will you put? You'll have to put it in Git. So if anyone has any such notions that I don't need Git, so no, you're wrong. you will need. If you are working in technology, somewhere down the line you will be using this tool. Okay, so keep that in mind. So yeah, let's go and talk about a bit of Git. Before we talk about Git, let's talk about what exactly is version control. Okay, and how did this version control came in picture. So version control is known as source control, is a practice of tracking, managing changes to the software code. Now before you deep dive into this definition of a typical definition of version control, let's understand from where did this version control came in picture. First of all, let's go back 10-15 years back and what we were exactly doing without this version control. Now imagine I'm a developer. Okay, I have created an application. That time I was not using any version control. Okay, so I've written my source code on my local system using a folder. I've created everything inside the folder. Now till the time I'm working alone, I have no issues. I can go and make changes. I can create new packages, add new features and things like that all by myself by creating multiple folders. Like suppose I've created one folder, I've deployed my application. Now there's a feature change. I've created one more folder, named that it's feature 1.1. I've kept my source code in it. Then I have new feature 2.1. This way I'm creating folders manually by myself. And it's all because I'm working alone. I have no issues. I know what I'm doing right now. Now there are a couple of more people joined in my team. Now I need to share my code with them, source code with them. Great. How do I share it? I share it using an email. I attach it and send it across to them, or I'll have a file share server. Correct? We have set a file share. Correct? So I'll have a file share, and in the file share I'll keep my source code. Now the other developers started working on the feature. Now even they started creating all the folders. They have their own folders, I'll have my own folder, the other developer will have their own folders, and this way three of us, we are just three of us. Somehow we are managing, we are creating different folders. Then we are telling them, okay, this is the folder I created, this is the new feature was added. Somehow even this is looking very clumsy now because everyone is creating their own folder. Which one is the code, which is the latest code, we don't know. But somehow there is a great coordination and somehow we are managing. Now my team has increased exponentially, plus my application has also increased. Like it has grown like anything. It's a very popular application. It has grown, and even my team has started increasing. From 3 we are 5, from 10. Now do you think it's possible for us to go and manage these folders? I need one people just to manage this folder for me. Go and who is doing what is the latest change, who is working on the bug, who is working on the feature, who is working on the issues. All this becomes very difficult now. Managing this folder becomes very difficult, even though we are using all the latest technology of file share servers and we are trying our best to manage. But this eventually at one given point of time everything will crash and people will not even come to know which was the latest version, which was the production version, and things will go haywire. So this was the difficulty faced by development team initially when they had a thought of version control. One or two developers managing together is easier. Even it's not easier, guys, because creating manual folders, it's never a solution. Sharing code over an email attachment is never a solution. Sharing code on a file share path is never a solution. Okay, that was some sort of shortcuts, and still you will find many companies wherein they have not used Git and they are literally sharing code over an email and sending across to the development. There are companies, guys, forget about the companies. I have worked in one of the project wherein I have seen this practice. Okay, wherein I have automated everything, but this was a practice before automation, wherein they were literally attaching SQL scripts over an email and sending across to the DBS for running it on the production. Later we have automated everything, we have automated the complete database. Now everything is going through pipeline, but this was the practice, and I'm talking about the previous year when I completed this project. Okay, so yeah, so it's there, it's not alien, it's there. Okay, so that is what Git does. Not Git, I'm not talking about Git now. That is what version control tool does. So version control is the practice of tracking and managing changes to software code. Version control keeps software track of every modification to the code in a special kind of database. So version control has its own database, guys, so you'll not even come to know where exactly the database is. So version control maintains its own database, and it maintains a track whatever for modification you're doing. So like, what did I say? Whenever there is a new feature, we are creating a folder version 1.1, and they're keeping the new feature in that folder name. Now this is all done automatically by version control tools. Whenever there is any sort of modification, they keep a track, they create a new commit ID. What exactly the commit ID is, this all we'll talk about later. For now, there is a special kind of database wherein they put all this information and they keep it in the databases. Version control tracks every developer change and helps prevent concurrent work from conflicting. This is again a very important feature of version control. It will track every developer's change, and based on it, it will help you prevent any concurrent work. If there's any concurrent, like if someone is already working on that file, or if someone has already worked on that file, it will give you a clear-cut error stating there was changes in this file. Based on that, you can decide which change you want to take. Okay, so that is what this version control tools are all about. Okay, so this is what version control is. What is the main responsibility? Tracking and managing changes, keeping every modification in a special kind of databases, making sure there's no concurrent work conflicting. Okay, these are the features which made many people's life very easier, mainly in development world, because prior to version control, development world was a complete mess. Okay, let's take it this way. Okay, what are the benefits of version control? Enhances the project development speed, efficient collaboration, reduce possibilities of errors and conflict, employs or contributes to the project can contribute for anywhere irrespective of different geographical location. If I'm from India, you guys are from US. If I'm creating any software and if I want to share it with you, if I need your inputs, you can easily clone it at your local system and you can start collaborating to my project. That easy it becomes. Okay, for each different contributor to the project, a different working copy is maintained. This is, we'll talk about in details what is this working copy and all. Okay, for now just keep it as it is. The most popular example of version control is Git, Helix, Microsoft TFS. It can help in recovery in case of disaster, in case of failure. So we have working copy, it's like a backup created elsewhere, so you can have a you can recover it whenever you want. So these are the W's which it answers. Inform us about who did it, what changes were made, when exactly the changes were made, and why the changes were made. All these questions will be answered with version control. All the W's. Who did it? You'll come to know who was the developer who made the commit. When was it did? So you have the date and time and the timestamp you'll come to know. Why it was made? So all the description will tell you why exactly these changes were made. So this is all about version control. Now there are two types of version control, guys. Centralized version control, distributed version control. Okay, very popular tool in centralized version control is SVN, TVFS, Team Foundation Version Control, SVN. These are very popular till 2016. suppose that everyone knows Git has taken over everything. Okay, so SV and TFS, these are centralized version control. What exactly is the major difference in centralized version control and distributed version control? This will be definitely a short question in interview. Keep that in mind. Centralized version control system contains just one repository globally, and every user needs to commit to reflecting one changes into the repository. I know no one has understood anything. Let's understand this into a very layman term. Now in centralized repository, what exactly happens? You will have a central server. You'll have a central server, and these are all your workstation. These are developers. These are all developer systems. So what they do at the initially when they start working, what they do, they connect to the central server. They clone the repository on their local. Cloning is nothing but downloading the entire source code on your local system. So along with your source code, you'll have your history and everything will be downloaded on your local system. Now I'm a developer. I have connected to the central repository. I have downloaded the clone copy on my local system. Very good. Till here we are all fine. Now when I start working, even for a smallest commit, like if I made few changes, a small minor, very minor change, and I'm not yet ready with my ready with my feature. So what did I, even for saving that small change, I have to connect to the central server again, update the central server that I need to save this small change. So basically you're committing that small change on a central server. So all even your smallest request is, in that case, you need to connect to your central server, inform your central server this is the small change, please update it. Then you commit it to your central server, then it will get updated on your local system also. So every transaction, each transaction, you need to connect to your central server. Keep that in mind. Not till here it's okay. Oh, there are multiple developers. No, it's not just me who is connecting to the central server. Imagine there are 100 developers who are working on the same project. If 100 developers are constantly connecting to the central server, there is a great issue. Very low speed. Everyone is trying to connect to central server. There is a great chance if the central server is down, all your underlying work is exposed. You guys are sitting idle. There's nothing you can do if the central server itself is down, because in centralized version control, that's why the name is centralized version control. Each transaction will be done through centralized server itself. You cannot do anything on your local. If you want to do any commit, go to your central server, ask your central server, this is the commit, please update it. Once it is updated, the other developer, if they want to access your commit, they can simply update the local copy and they will get those changes of yours. But the problem is the complete dependency is there on the central server, and if the central by any which ways it goes down, you are all the developers are sitting idle. They cannot do any development activity. Plus you have to connect to central server. Your transactional, your push pull, all these are very slow and very sluggish as compared to Git. If you guys have used SVN, you'll know what I'm talking about. I have used SVN during my college time. Okay, so this is what central version control is all about. Central version control system contains one repository globally, as I said earlier, and every user needs to commit to reflecting one changes into the repository. If you want your changes to reflect, you need to commit to your central repository. It is possible for others to see your changes by updating. So if others want to see your changes, they need to update their copy. Two things are required to make changes visible. You commit, they update. So if I commit and you update your copy, then you can see your changes. Now this is what is centralized version control is all about. Very known tool in centralized version control is TFVC VS. That's Microsoft Team Foundation version control, and SVN. SVN was the open source centralized version control. Now, what is distributed version control? Distributed, the famous tool is Git, the one which we use right now. Git is distributed version control. Now, what drastic Git has done, let's understand that. Distributed version control system can contain multiple repositories. This was the drastic change. The extra layer. This is what Git has done. Extra. All this is your centralized version control. These are your developer system. This is very similar to what we have in centralized version control. You have your central server, so I'm not denying that in Git we don't have a central server. Even in Git we have a central server, guys. The only difference which you will find out, that it is not dependent on the centralized server completely. If you see this diagram, your things are not completely dependent on central server. Now, what changes Git has brought? You got your central server. When the developer wants to work, they clone this repository to their local system. Okay, very similar to what we had in Git, central version control. They clone the copy to the local system. They have the local copy with all the history and everything. Now, only difference is, even on the local system they will have a local repository created now. Same like central server, the repository which is there in somewhere in the cloud, in the remote, whether you're using GitHub, GitLab, Bitbucket, Azure Repos, whatever it is. So your remote repository is there somewhere in the cloud. This is somewhere on the cloud. And when you clone it, when you clone this source code, you will have a local copy on your local system also. On your local system you will have a Git server. Just take it that way. It's a repository which gets created, which will have all the features of committing, pushing, pulling, everything. You will have it on your local system itself. So that was the major change. Now, when you're being a developer, when you're working, and if you want to make all sort of commits, all sort of update, you don't have to connect to your central server. What you have to do, you just have to simply commit to your local repository. All your changes will be committed to your local repository, and when you're ready with all your features, that my features has been developed, I have tested my feature locally, now I'm ready to push this change to my remote repository wherein everyone can use it. At that time, from your local repository you will push your changes to the remote repository. At that time, like when you're done with your complete development activity, at that time you have to push it. Now, if I talk about if the central server is down, is your developers are impacted? No, they have their own local copy. They can still work. They have their local copy on the system. They can still work. They can wait while the central server comes up, then they can push it. What if this central server gets corrupted? They have the copies on the local system. So it's like a backup which you're taking. If you have 100 developers have cloned already, and you got 100 backups of your source code already there. You can recover very easily from anywhere. Very important, transaction. You are not connecting to internet to your central server for doing any sort of transaction. That is done at the very end. All your transaction is happening on your local system locally. All your transaction is happening on your local system locally. Do you think how fast Git would be as compared to the other version control tool? So that is the major change what Git has brought. And let me tell you, before Git, SVN was the highly used version control in the world. And when Git was introduced after 2015-2016, people started literally migrating from SVN to Git. Nowadays, very rarely you will find any SVN repository. Everything has been migrated on Git. Now let's go and read through the definition again. Distributed version control system contains multiple repositories. So yes, we do have multiple repository. Each user, now the best part is each user has their own repository and a working copy. User needs to pull to fetch the latest changes, whereas the developer needs to push their changes to update the remote repository. To make changes visible, you commit, you push, they pull, they update. So when you commit your changes to your local, then you need to push it. What do I mean by push? Pushing the changes to the remote repository, and if anyone else wants to view your changes, they need to pull the change on the local and they will update. So this is the major difference between distributed and centralized version control. Anyone, any question? This is very important. Anyone? Any confusion with the centralized of anything as such? No questions, guys? Okay, let's move on. Okay, these are some benefits of using Git over SVN. So why exactly we are using Git? So I already spoke about many benefits, many doubt. Let's see what exactly we have. Git utilizes multiple repository concept, a central repository and a series of local repository. Local repository is exact copy of central repository with the entire history changes, unlike SVN. This is a major difference, guys. Git has a central repository and a series of local repositories, which is nothing but it's an exact copy of your central repository, which will have all your history. History, when I say history, is very important. History, this is the history which will answer all your W's. Remember, who, why, when, what, all this will be answered with this history. Okay, so that's why it's very important. The Git workflow is very similar to SVN, as we have already seen it, but an extra step. To create a new feature, you take the exact copy of central repository to create a local repository on your local machine. So that is only extra thing which is added. This extra layer of repositories has been added and distributed. Many developers prefer Git for the following reason. It has faster commit. We know the reason now why it is faster. No more single point of failure. If the centralized server is down, the developer can still work using a local copy. Make sense? It is available offline. TFS works on the concept by value, whereas Git works on the concept by reference. Now what exactly this means, it's very important. TFS, guys, Team Foundation Version Control, I'm talking about. TFS is also a centralized version control of Microsoft. Now if you want to know more about Azure DevOps, Azure DevOps was also completely based on centralized version control, that is TFS. It was previously known as TFS, Team Foundation Server. That was a Microsoft tool before 2019. Now Microsoft was very aware that if they don't go with the trend, they don't go with the latest technology, sooner or later this tool will be out of the market. So in the year 2019 they acquired GitHub, if you know the news. Not completely, partially. GitHub still open source, but partially they have acquired GitHub and they have integrated GitHub with TFS tool, which is today known as Azure DevOps. So Azure DevOps is not a new tool, guys. So it's a TFS has been renamed as Azure DevOps, and the GitHub which they have acquired is known as Azure Repos. Okay, and they have integrated Git with Azure DevOps, and that was the major change what Microsoft did. And now Azure DevOps, we all know this is one of the best CI/CD tool in the market. If you see the trend, This is all because they were not using Git, because Team Foundation Version Control, it's their own tool. This is a Microsoft proprietary tool, so they were not willing to go out of the centralized version control to the distributed version control, but they knew it. They have to integrate Git. If they don't do it, there's a big chance that they will be thrown out of the market. Now they came with Azure DevOps, and prior to Azure DevOps, if anyone has used TFS, guys, it was very slow, very sluggish, and it was not up to the mark. So that's why people tend to go to Jenkins and things like this. Okay, now after this Azure DevOps came in picture. It's not just a CI/CD tool, it's complete umbrella wherein you get everything. Okay, you don't have to, if you're looking for a solution, complete solution without moving here and there, then Azure DevOps is a solution for you. You don't have to you don't have to jump here and there for any sort of solution. If you want to do a build, if you want to do a release, if you want to do a work item management, if you want to do artifact management, if you want to do a repository management, if you want to connect to any cloud, all can be done in one single location. Okay, so we'll talk about that later. For now, okay, so this is bit of history about TFS. So what do I mean by work on the concept of value and work on the concept by reference? So this means the total number of branches in TFS is actually a total number of physical folder. If you're creating a branch in TFS or SVN, that is something you're creating a physical folder on your local machine. And on the other hand, in the Git, the total number of branches are logical, and only the reference or the pointers moves ahead and back with each branch. So when you create a branch in a Git on your local system, this will just a reference. You'll not physically see any development branch or any main branch is getting created on a local system. It's just a logical branches which will be created, and there is a pointer. I'll show you what exactly header pointer I'm talking about. The pointer is just moving up and down and helping you with all the things. So that was the major difference why this thing is very fast as compared to others. Okay, so this is about a bit of version control, guys. What is distributed version control? What is centralized version control? What is the benefit of distributed over the centralized? This is all interview questions. If you're going for a DevOps interview, just make sure you know the difference between distributed and centralized. Why will you use Git? That is very important question. And what is Git? Git is a version control tool. Don't confuse yourself with GitHub, GitLab. These are cloud providers. They are just, in a very simple term, if I want to explain you, they are a location on cloud wherein you're storing your source code. That's it. Other features what they provide, that's a different story. There are so many features they provide nowadays. Okay, but what is the core responsibility of these cloud providers? They provide you a space on cloud wherein you can store your source code. As simple as that. Okay, keep that in mind. Okay, Git introduction. Git is fast, scalable, distributed revision control system with unusual rich command set that provide both high level operation and full access to internal. This is very important, unusual rich command set. So using Git from the command line, if you know how to work with Git from the command line, you can do maximum things. It has so many commands, it has so many feature exposed at the command line, that the things which you cannot do at the GUI using the graphical user interface, that things you can be done easily using command line. Hence we'll spend couple of days understanding this command line. See, I'll teach you Git from multiple ways. I'll teach you the first way. I'll teach you from the command line. The second way, I'll teach you using graphical user interface, that is Azure repos, wherein I'll show you how to use Git from that perspective. The third way I'll be showing you using Visual Studio tool. So you will be using Visual Studio, and through Visual Studio I'll show you how to work with Git. So I'll give you three options. So in this three option, whichever you like, you can go for it. Okay, but make sure you are very familiar with command line. The reason is, when this Visual Studio tool and this graphical user interface fails, the only things which will come as a savior to you will be the command line. I have seen it in many cases, guys. See, literally, when I'm pulling a request from Azure repos, the great chance that Azure repos has some issues. It will not let you pull things. There are merge conflict which you cannot resolve it on the website. Then you have to come locally and do it. So yeah, from the command line, if you know how to do things, there's no stopping. And in any situation, you can come out if you know the command line. Okay, so keep that in mind. Command line is very important. It's not optional. We already talked about what exactly distributed. So it's a distributed version control, is a form of version control in which complete code base including full history and mirrored on every developer's computer. So we have already seen the diagram. Okay, it enables automatic management, branching and merging, speeds up your operation, improves ability, work offline, and does not rely on single location for backups. Make sense? This is all we have seen how exactly it all happens, correct? Okay, anyone has any questions till now? Any doubt? Because we'll start with now practicals, guys. So make sure if you have any doubt with the theory, ask it right away. No questions? Perfect. Okay, now let's go to your local system. Okay, now let me create a folder on my desktop. Let's name it as git test. Now this is a very simple folder. Now if I create anything, if I create a file to it, test1, and if I write anything to it, hello world, okay, I have the file and I have written hello world. Do you think if I delete this file, people ever will come to know that there was a file inside this folder? If I go and delete this file, like delete this file, do you think people will ever come to know that there was a file inside this folder? What do you guys think? If I give this folder to you, will not come to know, correct? Because this is a very simple folder what we have created. This is not a Git folder right now. Can I convert this local folder into a local Git repository? The answer is yes, because you got Git installed on your local system. And if you want to convert this local folder, this is the local folder, guys, into a Git repository, a local Git repository, then the answer is yes, we can do it. After that, Git will start taking care of things. Now where exactly this folder is? This is on my desktop. So pwd, it's for parent working directory, guys. Hopefully everyone remember it. And where we need to go? We need to go in desktop. So cd desktop. What is the name of the folder? cd git. Okay. Now if I try to run any git commands, no. So what is the error I'm getting right now? See this error. Not a Git repository. Okay. So this is the first command which you get it, not a Git repository. So the first command which you will run if you want to make this Git, I'm talking about this folder. I'm currently inside this folder right now. you cannot go one step behind, and you cannot, where exactly you are at the desktop right now. And if you do run git commands over here, your complete desktop folder will become a local git repository. Don't make that mistake. Okay, that's why I purposely created one folder, that is git test, and I'll make changes in this folder. Only this folder will be my git local repository, not all the complete desktop. Keep that in mind. So the first command which you will run is git init. What exactly git init is? Initializing local git repository. What is the command? Git init. It will initialize a local git repository. What did it do? Initialized empty git repository. Where exactly it is initialized? Inside this folder. Initializing means nothing but it will download all the required binaries and it will create a local repository for you. The binaries are needed for your git to work. Okay, now when you did a initialize, automatically see the difference. You get something master attached at the with the folder name. So that means there is a branch got created. What exactly is branch? We'll talk about that later. For now, this folder now become my git repository. Now when I run the command git log, it's not an error. Your current branch does not have any commits yet, so it's not an error now. It is telling there's no changes. You don't have any changes right now on your local system, on your local repository. Now this is, see the difference. If I just go one screen back, one folder back, and if I run the command, see the error? Not a git repository. So desktop is not a git repository. This folder is a git repository. That is the difference. Sorry. Okay, this folder is a git repository. Now git will start keeping things, tracking things for you. There are 3 stages of git. There are 3 stages of git. Okay, one more thing. When you initialize, there is a hidden file which gets created. It's a .git file. Okay, this is hidden. This is why exactly visible, because if you go in my views and if you see, there is a hidden item I have checked box. If I just remove it, the .git folder will be gone. Okay, so this is how hidden file, you can view it in Windows. And if you go inside this hidden file, this is, you can see, this is how git is maintaining everything. Okay, you got your head, what exactly is head and things we'll talk about. Your configs, your reference, your objects, everything is right over here in this screen. Okay, so this is how git will be managing things for you. Tomorrow if you want to take a backup, or if you're moving it from one system to other system, then you can simply copy this folder .git. You have to copy this folder if you want the complete history along with your source code. Copy it, put it wherever you want, and your git will start from there. Okay, like suppose tomorrow if I'm going somewhere, I want to move out of this system, I'll copy this entire folder and keep it wherever I want. I'll have all my changes along with my history, along with my branches, everything as it is, whatever I have created. Okay, so that important that file is. Now if you want to view hidden files in Linux, the command is ls-a. You can see the hidden file. Okay, I was talking about 3 stages. Git works in 3 stages. The first stage is working directory. The second stage is staging area. The third stage is the local git repository. Then if you want to add a 4th stage, then you can have a 4th stage, remote repository. Okay. Now for now we are not talking about remote repository. We just focused on these 3 stages right now. Later I'll talk about remote repositories also. Okay, so working directory. Now you are inside this folder, git test, and there is a cursor blinking. Now this becomes your working directory, guys. Whatever you do now, like if I'm creating a new file, hello world, these files which I'm creating, just imagine these are your source code. What exactly these are? These are your source code, guys. Just imagine that I'm creating a source code file. So this, where exactly I'm making changes, this is my work directory. In my work directory I'm making the changes right now. If you view, I got a hello underscore world.txt file. Why do I call this work directory? If you run the command git status, okay, what all git command did I run? The first git was git init. Git init is to initialize a local git repository. The second command I run git log. I'll talk about log again. Git log is basically give you log information what all commits was made. The third command I ran is git status. Git status will basically check for tracked and untracked files. Remember this word, tracked and untracked file. There's a scenario based question. How do we check tracked and untracked file in Git? This is the question. Your answer should be git status. That's it. Okay. Okay. Now if you see hello underscore world, it's in red. This is untracked. So Git is not tracking right now. Git is not tracking anything right now. Git is telling you that in your working directory there was a file added which I am not tracking as if now. Do you want me to track it? So once you track it, then the file goes into the next stage, that is your staging area. Okay, so after your working directory, if you want Git to track, then there's a git add operation which you need to perform. After the add operation, Git will starts, it goes in the staging area, and then Git will say, okay, this is now I have that file with me. How exactly you do it? You do it with the command git add followed by the file name. And all thanks to bash, you can just do hello and do a tab. You have the auto completion. So this is all because of bash which is happening. Okay, if I do a add, now if you see git status command, do you see things are getting tracked by Git right now? You have added it, things are staged, and it's there in the staging area. Okay, now Git maintains a special kind of database. As I said, not just Git, all this version control has a special kind of database, correct? Wherein in the database all this information, file information, needs to be updated. Okay, so same goes with Git. Git maintains a special kind of index file. Anyone over here knows indexing? What is indexing concept? Anyone, guys? How many people do I have?
Yeah, to fetch the data in a fast way. Indexing is using database, right?
Okay, good. Anyone else wants to try? I got 14 people, guys. Indexing. In a simple layman term, how do I call up indexing? Very simple. I don't want technical jargons. In a very simple language, what is indexing? No one?
Yeah, it's arranging in sequential manner.
Arranging in sequential manner. Good, good. Okay, let me take it this way. Everyone has book in their house. Okay, so in a book, when you flip the pages, and if you're reading through a book, if
Yeah,
I
I think
ask you,
indexing just means like a reference or something.
correct, reference, that is the word. So in the book, the first page, it's an index page wherein you get the chapter 1 is there on page number 10, chapter 2 is page number 30, and if you want to go to chapter 5, you just go to the index page, see, okay, the chapter 5 is on page number 70, and you directly flip to the page number 70. Accessing becomes very easier if you have indexing, correct? Now just tear out the indexing page from that book itself. Now if I am asking go to chapter 10 for me, how will you go? You will start flipping one page at a time. Then eventually you'll land up at page number 150 where the chapter 10 is there. This becomes time consuming. It will take up your complete compute. It's time consuming and it is very slow and sluggish without indexing. Now understand the importance of indexing. Very good, Bharti. Unordered into an ordered way. Very good. So this is what indexing means. Same concept. So wherever in the databases also you hear the word indexing, this is nothing but a reference through which you, if you want to access data, then directly you will land up to that data. Okay, because if you don't have indexing in your database, then you'll have to go one block on your hard drive at a time to fetch that data, and just for a simple select statement it will take an hour without indexing. Same concept Git also follows. So when you have this information, when you staged your file, basically this file needs to be committed, and the commit, what exactly commit does is nothing but it's going and creating an index file. As if now if you go and see the .git file, there's no index. There's an index file, it's of 1 KB, and if you go and view it, you will not find any commits right now. Okay, so when you do a commit, basically what will happen, an index will be created in this index file. Over here it will be created. Okay, so this is how indexing, this is why I said this .git file is very important. Everything is happening from this .git file. So an entry is created inside that file. This is how Git is managing things. So ever you want to access the commit again, you can simply reference to the commit ID and you can reference it. So that is the third stage, guys. After the staging area, the third stage is when you commit. When you do a commit, so basically the changes are getting updated into your local Git repository. So basically in the backdrop the index file is getting updated. Git commit will basically commit your changes to your local repository. Commit your changes to a local repository is nothing but it will go and maintain and update the index file, through which Git will make sure that the file is tracked completely now. Okay, that is your third area when you want to do a commit. So the Git commit, enter. Now this is some weird screen has come up. Anyone can tell me what exactly the screen is? What it looks like?
Like a Vim
Yeah.
text editor?
Yes, perfect. This is a Vim editor, guys. So if you want to do a commit without a description, you cannot commit anything. You need to tell Git why exactly this commit is. You need to give a commit message. Okay, so and this is keep in mind whenever you are introducing Git to someone, or if you're like in your companies, if you're training someone on a Git, make sure ask the developer to put in a very descriptive message what exactly this commit is, because based on this message you will be looking it into the history. You will be finding what exactly was done over here. So like me, how do I edit this file, guys? If I want to add something, how do I do it on this Vim? What is the first thing I need to do?
Insert.
Perfect. So added, what do I do? Hello world text file. Okay, now how do I come out from the insert mode?
Escape.
Perfect. How do I save and quit?
Control, what do you call this? Column and
Semicolon.
WQ.
Perfect. Done. So I did a commit now, and now if you see, added hello world text file, one file change, one file inserted, created mode, hello world. Now if I go and look into git status, I'll find nothing. So in my working directory there's nothing. My working tree is clean. But how do I see my commits now? Git logs. Oh, this is log, not logs. Git log. Commit ID. This is a pretty big commit ID, and this is unique, guys. You don't have to refer to the entire commit ID. The first 7 digit is more than enough. If you want to refer, this is unique. The first 7 digit is unique. Head master, just ignore it for now. What exactly this head is and what this is master, I'll cover this tomorrow. Author also ignore it for now. From where I got this details, Rohit Kumar Singh, and this I'll inform you how exactly I got this. Okay. Date, this is a timestamp, so it's taking my system time right now when the commit was made. And very importantly, this is the message through which you will come to know what exactly the commit was made. Okay. In my case, guys, the commit happened instantly. In your case, when you're cloning the git when you're installing the git for the very first time, it will not let you commit. The reason is there are 2 requirements to commit. The first requirement is email ID, and the second requirement is username. So git wants to know who is doing the commit first and what is the email ID. This 2 information minimum requirement for doing any sort of local commit. In my case, because I'm using git since very beginning, I have this information there in my config already. In my git configuration, these informations are there already. How do you check it? There's a command git config -l, and do you see this? User.email, user.name, and these are all other information related to git. But for now, you'll need to focus on this 2 information. Okay. How do you add this information? Now that's your second question. Adding this information is very easy. Git config. What is the first thing you need to enter? User.name. Name should be DevOps Mailer. What is the second thing you want to add? Get user.email. Oh, email is wrong. Perfect. This is not added. Let's use local. Guys, kindly put yourself on mute. It's there. There are two information, so I may have to remove this also if I need. But if you see this got added. Okay, makes sense, guys. This is what command, and don't worry about the commands, guys. It's there in my next slide. Whatever we do, and I think I have a notepad. I think in my previous session I have created a notepad also, which I'll share across, which I think has all the commands. Not sure. Yeah, see this. Yeah, perfect. This is things how it will be done. Okay, I'll be sharing this with you guys for reference. For now, wait. I think someone is not on mute. Satish. Okay, so I'll stop over here, guys. We'll continue tomorrow. There are many things which we need to talk about in Git. So if anyone has any questions, please do tell me, or we can wind up the call today.
Yeah, please just send us the command so we can play with it before the next session, please.
Yes, I'll share everything. So this is, I have already written all this. I'll just share it with you. Just make sure these are the commands which we did today: git init, git status, git config, git add, and don't do this part till here we have done it. So I'll continue further tomorrow, then wherein we can talk about git commit and all. Okay.
Yeah, I have a question. I mean, it's out of Git. It's just based on what you said about Azure DevOps. So I'm just curious. I want to know: is it possible for you to use a tool within Azure DevOps with another cloud platform?
Yes, I'll be using it. So next, this is, we are just focused on local git right now.
No. I'm just
Later,
asking. I'm asking about Azure DevOps. I said, is it possible using a tool within Azure, like just using the release tool in Azure DevOps to use it with another cloud platform, say AWS? Is it possible? Or it has to be Azure within Azure?
so you want to use Azure DevOps with other cloud platform tool like AWS. That is the question, correct?
Yes, is it possible?
Yes, why not? It is definitely possible. If you suppose, for an example, if you want to use Azure DevOps just for your build, but later you want to do your deployment on AWS EC2 instance,
Okay.
that is possible. You can. So Azure DevOps has all the plugins, whatever you required. You can
Okay.
plug your Azure DevOps with Jenkins also. Like
Okay.
suppose you want to use Jenkins as your build tool, your integration tool, and later you want to deploy things using Azure DevOps on Azure Cloud, for example. Even that is possible. If you want to integrate with GCP, even that is possible. If you want to integrate with Jira, that's a different work item tool, correct?
Yeah.
Even that is. So all the plugins are possible. Whatever you can think of, whichever tool you can think of, there is a plugin available in Azure DevOps which you can plug it in. We'll be using such plugins. Later in my course, I'll be showing you how to integrate with SonarQube. I'll show you how to integrate with Slack. How do you send messages on Slack channel and things like that. We'll be coming up with, I'll show you how to work with these plugins also. Don't worry.
All right. Thank you.
Okay. Anyone else? Any questions? Okay, so takeaway, sharing this PPT, sharing these commands, make sure to practice. Tomorrow we'll continue with Git. Okay guys, thank you very much. Bye bye.